For decades, Neptune was treated like the quiet planet at the edge of the solar system. Then James Webb looked closer, and the deeper scientists examined the planet, the less Neptune behaved like they thought it should.
We're on a journey to the edge of the bubble the sun creates around itself. Outside is interstellar space.
The only time humanity ever visited Neptune was August 25th, 1989. Voyager 2 had traveled for 12 years to get there, covering 4.4 billion kilometers, before getting only a few hours to study the planet up close. Edward Stone, Voyager's project scientist, later described it as standing at the edge of something completely unknown, knowing they were seeing this world for the first and possibly last time in their lifetimes. The scientists at JPL watched the data arrive in real time, and then Voyager kept going. That was it. One visit, one afternoon in 1989. No orbiters, no landers, no return missions. For 35 years, almost everything we knew about Neptune came from that single flyby and telescopes that could only see it as a tiny blue circle in the dark. Voyager immediately found something strange. Neptune's winds move at more than 2,100 kilometers per hour, faster than the speed of sound, faster than any winds recorded anywhere else in the solar system. The strongest hurricane ever measured on Earth reached around 315 kilometers per hour. Neptune's atmosphere moves nearly 7 times faster than that, not during a storm, just on any given day. And despite existing at the outer edge of the solar system, Neptune radiates far more heat than it receives from the sun. The sunlight there is incredibly weak. At that distance, the sun delivers less than 1% of the energy Earth receives. Yet the planet still glows from internal heat that scientists cannot fully explain. Something deep inside Neptune is generating energy we still do not understand. Voyager also photographed the Great Dark Spot, a storm roughly the size of Earth, spinning through Neptune's southern hemisphere. When Hubble looked again just 5 years later, the storm had vanished completely. Not weakened. Gone. New storms appeared elsewhere instead, moving and dissolving on timescales that no planetary model has cleanly explained. You'd think that would be enough to make Neptune interesting. It wasn't even the beginning. This is where James Webb enters the story. Webb was designed to study the early universe, but its infrared instruments can observe planetary atmospheres with a sensitivity nothing before it could match. In 2022, scientists turned Webb toward Neptune for the first time. What came back immediately surprised them. Neptune's rings, always faint and blurry through older telescopes, suddenly appeared sharp and clearly defined. Thin arcs of ice and dust surrounded the planet with a clarity no previous instrument had captured. They were always there. No one had ever been able to see them properly, but the rings were only the beginning. Webb also detected Neptune's auroras with unprecedented clarity. On Earth, auroras form near the poles because our magnetic field is relatively stable and aligned with the planet's axis. Neptune's magnetic field is not. It is tilted 47 degrees away from the rotation axis and offset from the planet's geometric center, generating auroras in unexpected locations that shift in ways scientists are still trying to map. Heidi Hammel, who has studied Neptune for over 3 decades and serves as Webb's interdisciplinary scientist for solar system observations, described the infrared data as opening a window that had simply never existed before. Not a correction of what Voyager showed. An entirely different layer of the same planet, and some of what that layer revealed still has no clean explanation. What made everything stranger was how active Neptune appeared given where it sits. At Neptune, sunlight is almost 1,000 times weaker than on Earth. The sun would look less like a blazing star and more like an unusually bright point of light in a vast, dark sky. If you were somehow suspended in Neptune's upper atmosphere, you would feel no warmth from it at all. By every normal expectation, Neptune should be cold, slow, and mostly dormant. Instead, Webb was watching a planet churning with violent atmospheric motion, shifting cloud structures, and heat rising from somewhere deep below anything visible. The further scientists examined the data, the harder Neptune became to place within familiar planetary behavior. Then the temperature data created a new problem. After Voyager's flyby, many researchers believed Neptune was gradually cooling as it moved through seasonal changes. But newer observations showed parts of the atmosphere warming instead, including regions near the equator and South Pole, on timescales that don't match existing thermal models. Some researchers point to internal heat dynamics, others to methane chemistry, cloud feedback, or distant solar activity. None of the explanations fully fits. And then there is what lies beneath the clouds. Neptune is classified as an ice giant, but conditions deep inside are almost impossible to imagine. Pressures reach millions of times Earth's atmospheric pressure. Temperatures may exceed 7,000 degrees Celsius. Under those conditions, carbon from methane can compress into diamonds, real diamonds, potentially forming and falling as precipitation through the planet's interior. Laboratory experiments at SLAC National Accelerator Laboratory confirmed the physics for this process can exist under Neptune-like conditions. Whether it happens at scale inside the planet is still unknown. That is where Neptune leaves familiar ground entirely. From the outside, it looks calm. Beautiful even. A deep blue world quietly circling at the edge of the solar system. But the planet has no solid surface. Descend into the atmosphere, and there is no ground to find. Only layers growing denser and hotter until gas becomes exotic pressurized fluid, conducting electricity like liquid metal, generating a magnetic field unlike anything else we know. The deeper scientists look, the less Neptune resembles anything they were trained to expect. Voyager 2 is still out there. It crossed into interstellar space in 2018 and is now more than 20 billion kilometers from Earth. Signals take over 18 hours to arrive. It runs on instruments designed in the 1970s, drawing less power than a household light bulb. Edward Stone and the scientists who built Voyager spent their careers on a planet they visited for one afternoon. James Webb has now given researchers more detailed atmospheric data in a single campaign than humanity collected during the previous 3 decades combined. What Webb is revealing is not reassurance. It is the realization that Neptune is a world that behaves less and less like anything familiar, and we have barely begun to look.